So our next video is going to continue talking about our congruence postulates. But first we're going to look at some vocabulary. Now a lot of this vocabulary you've already seen or you know pretty much what it is, but we're just going to put it all in one place with some nice definitions. So we'll start off with our vertical angles. We talked a little bit about this today, and vertical angles are the two non-adjacent angles formed by two intersecting lines. So if we have our two intersecting lines, we have A, B, C, D. In this case, our vertical angles, angle A and angle C, are vertical angles, and angle B and angle D are vertical angles. Now we went a little farther and we talked about how they're congruent, and that comes from our vertical angle theorem. The vertical angle theorem says that if two angles are vertical angles, then they are congruent. So we have the definition of vertical angles, and then we know they're congruent because of the vertical angle theorem. So in our drawing, angle A is congruent to angle C, and angle B is congruent to angle D. Okay, let's talk about the midpoint. And I know you guys kind of know what a midpoint is, so here's a definition. It's the point on a segment exactly halfway between the endpoints of the segment. So if we have segment AB, our midpoint, we'll call D, splits this in half. So we can put a dash there and a dash there because AD is congruent to DB. And we talked about the reflexive property. Now the reflexive property was just something that is congruent to itself. So if we look at our diagram up top, angle A is congruent to angle A because it is congruent to itself, and that is the reflexive property. Alright, we'll talk about an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So if we have, say this is CAD, right? An angle bisector comes right down the middle, and it makes, we'll say a point here is E. So it makes angle CAE congruent to angle EAD. Just cuts it in half. We have a segment bisector. A segment bisector is a segment, line, or plane that intersects a segment at its midpoint. So we could have something where we have a segment. This is AB. Right? And we could have another segment, line, or something that cuts through it. And this could be our point F, which is our midpoint. So again, this is congruent to this. So AF is congruent to FB, and this could be a line that cuts through there. We also have a perpendicular bisector. That is a line segment array that passes through the midpoint of a segment and is perpendicular to that segment. So this is very similar. So we have our A and our B. And then we have our midpoint at F. So we know that those are congruent. AF and FB are congruent. Now a perpendicular bisector cuts right down the middle and makes this a right angle. I'm going to have to erase this because we have one more definition. Let me just erase this real quick. Now our next definition is perpendicular. Alright, so perpendicular is just the line segments or rays that form a right angle, which is 90 degrees. Okay, our next thing we're going to talk about is just a little review. So first, I do want to say that I want you guys to all remember that if you say XY with no segment symbol, that's talking about the distance, the length. If you want to talk about a segment, you would say XY and you would write that segment symbol on top. So if you want to say the lengths are the same, you would say xy equals, and you could either say it equals a certain length, like 5 or 10, or you could say that the length equals zw, or you could say that segment xy is congruent to segment zw. So if you're talking about the length and the distance, you would use an equals, and if you're talking about congruent, if it's congruent to a segment, you would make sure you use that segment symbol on top. Okay? So we talked about the side postulate. Alright, so if we're looking at a triangle here, this is like an example from the worksheet. This is looking at number 6. Okay? So we want to know if this is congruent and how we know it's congruent if it is, right? So we know that we have two sides here, one from each side, and then we have a second side. And this middle one, we could technically put a 1 there if you wanted to help denote that it's congruent because of the reflexive property, it's congruent to itself. So looking at all three sides are congruent in both triangles, that tells us that this is congruent by side. And if we look at number 14 on that page, this wants to know what we need to make this congruent by side. So we see we have a side with 2 dashes on both, so they're congruent, and we have sides with 3 dashes, so they're congruent. So in order to make this congruent by side, we would need the side that's left to be congruent on both. So we would write that we need RT, and we put our segment symbol, to be congruent to, and then we look over here and we have XZ. And make sure we have our segment. So we need segment RT to be congruent to segment XZ. We talked about a side angle side postulate, or congruency. Alright? So we have, this one is number 8 on the worksheet. So we want to see if it's congruent and just be able to tell how it's congruent or how we know it's congruent. So we see that we have a side with 1 dash, so they're congruent. We have angles that are congruent, and this middle line here is congruent to itself because of the reflexive property. So if we were to kind of redraw that bottom one and carry out our angles, we know that we would have this side, this angle, and this bottom side. So because of that, we know that this is congruent by SAS, side angle side. Right, looking at number 4. Right, we have these two triangles. We have an angle. We have 2 sides on each one. But if we look at them, this side, or this angle, is included. It's between these 2 sides. Right? This angle is not included. Okay? It's not included because it's adjacent to one side, but not both. So because of that, this is not congruent, or we don't have enough information to say if it's congruent. Right? It could be, if we were to actually measure or find some more measurements, but we don't have enough information. So we have not enough info. Alright, and then looking at number 17. Alright, this is where we want it to be congruent by SAS, side angle side, and so we need to figure out what we need for that to be congruent. So if we look, we have a side, and we know this one's congruent because of the reflexive property. So we have 2 sides. So we know we need an angle, and that angle has to be included because we have side, angle, side. Right? Order matters. So we look, and we have to have an angle that is adjacent to both of these sides, which would be this angle F. Right? But we can't just say angle F because that would mean the whole angle, and we need each individual side. So we would say that angle EFG needs to be congruent to angle QFG. Remember, it's important that the F is in the middle on both sides because that's the angle we're referring to, and the E and G and Q and G just lets us know which side of that angle. Alright, so now we're going to move in. We have 2 more congruence statements and ways of seeing if a triangle is congruent. And one is the angle side angle congruence, or ASA. And this says that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So if we're going to look at an example. Alright, this one tells us that we have two angles in each triangle that are congruent. So if we were to look at this triangle or these triangles, we know that we have the two angles and we also have the segment, the side in between that's reflexive is congruent to itself. So we notice that we have an angle, a side, and an angle. And an angle, a side, and an angle. Now what's important to remember about this is just like that included angle, we have included sides. Okay? It means the same thing where it's got to be adjacent to both of the angles. So and our order matters, so we had our other side, angle, side, and now we have angle, side, angle. So you kind of read it as you go. So we come down here, we have angle, side, angle. Okay? So this one is congruent, and it's congruent by angle, side, angle. Now look at another example. Again, we have the two angles, and we have this segment that's between both triangles, and so it's congruent to itself by the reflexive property. So again, we have angle, side, angle, angle, side, angle. So these are congruent because of the angle, side, angle congruence. And this one is just like the examples from the worksheet where we want it to be congruent by angle, side, angle, so we need to find what else we need. So if we look, we have an angle on both sides, and we have a side, right, the reflexive property. So if we have an angle and a side, we need another angle that would keep this side included. So we would have to look for this angle to be congruent to this angle. Right? The side has to be included. It's important. So if we want these angles to be congruent, we could write that as angle VHG has to be congruent to angle IGH. Right? We have angle H in the middle, G in the middle over here. The last one we're going to look at is angle side angle congruence, or AAS. Again, order does matter. And all this says is that if two angles and the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. So we have to keep in mind that we have two angles in one side, and we have to look at the non-included side, right, which is just the opposite of included, where it's not between the angles, but it's on the outside. All right. So for an example, we have this triangle. All right. We can see that we have two sides that are congruent and two angles that are congruent. So we have an angle and a side, and we're just missing another angle, right? So we know right here we have vertical angles, which makes these two congruent. So now we have an angle, angle, side. Keeping in mind that our side is non-included, right? Our included side would be between these two angles, and our non-included side is going to be one of these other two sides. So these triangles are congruent by angle, angle, side. Right? Then we've got another set down here. We've got an angle here, an angle here. We have an angle here, an angle here. Either they're right angles, they're still congruent angles. And we have the side in the middle that is, by the reflexive property, congruent to itself. So now we're looking at angle, side, angle. But that side is included, which is not working for angle, angle, side. So therefore this one is congruent, but not by angle, angle, side. This one is actually congruent by angle, side, angle. Okay? So important to keep in mind where that side is, whether it's included or not included. Alright, and this one is just like those other ones where we need to find what we need for these triangles to be congruent by angle, angle, side. So we have an angle and an angle, angle and angle, so we need a side. You've got to make sure it cannot be this side LM or this side YX, because those sides are included. We have to pick one of the other ones. So this one we have two options, right? We can have either YZ and NM being congruent, so we can have YZ segment, make sure you keep your segment congruent to MN, or we could look at our other non-adjacent side, which would be up here and right here. And so YZ has to be congruent to MN, or we could look at XZ being congruent to LN. Both of those segments being congruent, either or, would make it work by angle side.